Hi, this is about density. I know that you have already done some lab work on density, and I just wanted to reinforce that a little bit. So here I have some blocks, and in order to find the density, I need to know the mass. The mass of this guy is 3.53 kilograms. So I'll just write that down. 3.53 kilograms. And the volume of this guy, I'm going to use the same technique that you used in the lab. I'm going to dunk it in some water. And this water used to be 100 liters, see, and now it's 101.00 liters. So it went from 100 to 101. So that means the difference is 1.00, meaning the volume of that block was 1.00 liters. And so that is going to be 3.53. The units for density in this case are kilograms per liter. The units for density that you used in the lab were grams per cubic centimeter. Now I would like to show you here that kilograms per liter are the same as grams per cubic centimeter by doing a little conversion, the kind of conversion that you have already done for quiz number 1, I think it was. So here we have 3.53 kilograms in 1 liter. Now I'm about to convert this to grams per cubic centimeter. Right? Here we go. So I'll start with the kilograms in 1 times 10 to the minus 3. I'm sorry, I'm doing that backwards. In 1 kilogram, there are 1 times 10 to the 3 grams. So kilograms cancel. I have grams, so that's good. I'll keep those grams. Now I got these liters here. I'm going to convert that to centimeters cubed. And I know that in 1 liter, there's 1 cubic decimeter. This is a fact that you must memorize for Chem 65. And let's see, cubic decimeters. Yes, so liters cancel out. Now I know that in 1 decimeter, there are a certain number of meters, and that's this number of meters. But these are cubic decimeters, so I need to cube this whole thing. And I also, these are meters by the way, I also know that in this many meters, there's 1 centimeter. And this whole thing is cubed, and I want to cancel out these, well, these decimeters cubed cancel out, but I want to cancel out this meter cubed, so I might have to put this cube down here also. So meters cubed cancel out, and now I have centimeters cubed on the bottom. I got grams on top, centimeters cubed on the bottom, just like I wanted, grams on top, centimeters cubed on the bottom. And now I'm going to go through here and attempt to show that this kilograms per liter is the same as grams per cubic centimeter. Let's see if that works. 3.53 times 1e3, all right, so 3.53 times 1e3 and divided by 1e negative 1 cubed, so divided by 1e negative 1 cubed, and that's times 1e negative 2 cubed. So that's times 1e negative 2 cubed. And yes, that's still 3.53. So this is 3.53 grams per centimeter cubed. I'd like to give you some more practice problems about unit conversions, and I'll put those on the Chem 101 app for you. I'll let you know by email that that is available, and you should do that sometime before your next lab session. So I'll make that due on Tuesday at, I think I'll make it due at 12 noon. And that'll give you some time to prepare for your lab also. I don't want to do anything that's going to take any lab time away from you, because I believe that the lab is where most of the learning happens in a chemistry course for most people. This is another block. I just want to give you another example of this. 3.10 kilograms. 3.10 kilograms. I'll write that down. I'm going to find the density of this guy. Just put this block in here, and it doesn't sink. It floats. So this is the new volume of the water, and this is the old volume of the water. There it is, 100.00 liters turns into 103.10 liters. Now I cannot use 3.10 liters as the volume of this block, because 3.10 liters is not the volume of this block. It is the volume of the part of this block which is underwater. I need to use the whole volume, which means I need to put the whole thing underwater, like this. So it should be 3.38. 103.38 minus 100.00 is 3.38. So, hey, what happened to my paint window? Oh, here it is. So I'll divide this by 3.38 liters, and I will get the density 3.1 over 3.38. 3.1 over 3.38. Calculator doesn't care about significant figures. I just have to keep that significant figure in mind. There are three significant figures here. This is 0.917. So the answer here is 0.917 kilograms per liter. What is the meaning of all this? What does this density, these numbers, these calculations mean? Density means how packed together the matter is. So you could have, let's say, 55 pounds of stuff, right? You could have 55 pounds of feathers. You could have 55 pounds of bricks. Which one weighs more? Of course, the answer is they weigh the same because they're both 55 pounds. It's just that the bricks are going to take up a lot less space than 55 pounds of feathers. In order to achieve 55 pounds of feathers, you're going to need maybe a truckload of feathers. Do you know what I'm talking about? So there's a truckload. Here's a truckload, and inside this truck there are all these feathers. Feathers. If you have a truckload of feathers, then maybe you will have 55 pounds of feathers. You want 55 pounds of bricks? I think you can achieve that with 2 bricks. So 55 pounds of feathers weigh the same as 55 pounds of bricks. It's just you need a lot more of the feathers. You need a lot more space. So in this example, feathers have a lower density than bricks. That is the meaning of density. I'd like to share with you something else about density. Oops. How do I? I'll just make another one. Yes. All right. So here's another thing about density. You know, hot air is less dense than cold air, right? And therefore, hot air rises. Have you ever thought about why that is? So let's say this is a box, and in this box there are some air molecules. So if you have hot air down here, they form an air mass. There's just a group of hot air molecules. You have cold air up here. The cold air molecules will be closer together than the hot air molecules because we will learn in a few weeks that cold gases have a lower volume. They contract. And why do they do that? Well, we'll learn why in a few weeks. But why would the warm air molecules rise up above the cold air molecules? Why would that be? So we all know that that's what happens. That's why a hot air balloon rises, and that's why in your apartment or your home or in the building where you live, if you turn on the heater, usually, and if you stand on a chair or stand on a table, you will notice that the air close to the ceiling is hot, and you will notice that it is hotter than the air that is down near the floor. So if this is you and you're standing on a chair or a table, you will notice a difference in temperature. But anyways, why is that? Now I want you to understand why that is. It's because of gravity. So gravity is taking this air and giving it a downward force. Gravity is also taking this air and giving it a downward force. However, this amount, let me make those circles neater. So gravity is taking this air right. Gravity is taking this air right here, and gravity is giving that air a downward force. Gravity is also taking this air right here and giving that air a downward force. Okay, now which force is larger? Of course, the acceleration of gravity is always the same, but if there's more mass, there's going to be more weight. This has less mass. There's less weight. So the force of gravity, which is the mass times the acceleration, the force right here is larger because there's just more mass. So what does that mean? That means this stuff is sinking with a greater force than this stuff. So what does that mean? That means the hot air is not actually rising. What is happening is the cold air is pushing the hot air out of the way. So all of this is moving downward, and it is moving downward with a force that is greater than the force by which this is moving downward. So the cold air is coming down here with a large force compared to the force that's on these hot air molecules. And so the cold air is pushing the hot air out of the way. When the cold air pushes the hot air out of the way, that gives you the illusion that the hot air is rising. So this is why hot air rises. This is also why dense things sink in water and things that are not dense float in water. Is this dense? Okay. Look at this. This B has a low density. This D also has a low density. Both of these things are less dense than water. However, this E, as we saw, is denser than water. Therefore, it sinks. It's the same thing happening here. Gravity is pulling down on this water, but it's also pulling down on this block. However, the water is denser. The molecules of water are closer together than the molecules inside this block. Perhaps this block is full of air, or perhaps it is some kind of a solid where it's made of atoms that take up space, but the atoms are very light atoms, such as carbon or hydrogen. You know, this is made of completely of carbon and hydrogen. That would be lighter than water, which is made of hydrogen and oxygen. Oxygen being quite a bit heavier than carbon. But anyways, trying to say here that the water is getting pushed down by gravity with so much more force than the material in this block, that the water pushes, let me show you. The water pushes the block out of the way as the water goes down. And that gives us the illusion that the block is actually moving upward. Well, it is moving upward, but it isn't pushing its way upward. It is what is happening is the water is pushing the block out of its way, and so the block ends up moving upward. So that's all I wanted you to know about density. I'm going to make some problems for you in this homework assignment for density, whereby you will be able to use density to identify an unknown object. Density is very useful for identification of materials and that sort of thing. Thank you. Bye.